Hi, I'm Virginia Melnyk, PhD student at Tongji University's Digital Futures International PhD program and a lecturer at Clemson University. My paper is titled Sewing Pneumatic Complex Forms and Textures Based on the Human Body. Body form and proportion have often inspired architecture and design, and we see here Leonardo da Vinci's Vitruvian Man and Le Corbusier's Modular Man, which are very interested in the overall proportions and relationships of those proportions across the body, as well as perhaps in Neufert graphic standards, where we start to look even deeper at the positions of the body and how they can relate to our built environment, as well as those overall proportions. But tailoring and dressmaking has really been the more intimate way of measuring our bodies and understanding them, as clothing might be considered our first defense against the elements and the first type of architecture that protects our bodies. So each of these measurements has often been specific to your individual body. Today, fashion design comes in small, medium, and large sizes, which are not always specific, and often you buy clothing that doesn't quite fit that well. Modern technology has offered opportunities of 3D scanning mass amounts of bodies to begin to advance our understanding of the different forms and proportions of our human body by looking at different ages, races, weights, genders, and how those different bodies are shaped. And these 3D models that Alvanon has produced from these scans can be downloaded and used in computer programs for the fashion industry, such as Clo3D. But as well as just the overall proportions and understanding our bodies, I was also interested in skin and texture and the feelings of touch. Our hands have inspired art throughout history, where we can see the different veins and textures and wrinkles that are on our hands being beautifully shown through drawings. But I was not only interested in these sensations, as well as the way that our hands are our main sensory organ, which relates to our embodied consciousness of the world around us and how we relate and connect to the world. Our hands feel different types of sensations, space-like sensations, which we sense by moving our hands over an object, a body, or a form to see if it's bulbous and round, or is it rigid and boxy and geometric, as well as more finer sensations such as surface sensations, which are the textures that we can feel on the environment. And particularly here, the wrinkles and the different textures that are maybe embedded with our own skin. Touching is really important to our way that we connect to our environment and to people around us. And artists like Lucy McRae's body of work really looks at this lack of touch. As she says, we're entering a sort of touch crisis as digital technology has separated us from the people around by connecting through social media rather than in person, and reducing that tactility in our world. So these different wrinkles that we find on our body, I'm wondering if through the skins of pneumatic forms, we can generate these same tactile experiences to simulate and maybe create objects that you want to touch and maybe can give similar feelings for users or people within that environment. So going back to the tailoring and measurements of the body, I wanted to use that as being the most intimate way to connect, but also to create textures. So I picked up this old book off of my grandmother's bookshelf, and I looked at the different dressmaking techniques, and specifically isolated 3 that I wanted to explore, and used one per pneumatic structure to really analyze what the opportunities and results and possibilities could be for creating shape and texture in these pneumatic forms. given that typical pneumatic forms are usually smooth and don't have a lot of wrinkliness to the texture, I wanted to create something that had more texture. So the first sewing technique I picked up was darts, and these are used typically on the bodice or bust of a garment or in the small of the back. What I really liked about some of these sewing techniques for darts was that the pattern itself was super simple. So unlike a lot of pneumatic forms, which are smooth and use digital fabrication to create hundreds of small panelized pieces that are complexly reefed, sewn back together, I wanted to use these more simple forms and look at the sewing technique as an opportunity to begin to create shape around a body. And so with the darts, you can see it starts as a rectangle and just a few triangles cut out it, maybe a curve for the neck or armholes. And when sewn back together, it really creates a different shape and form that fits over the body. Resultantly, starting with the pattern, a way that you might work in fashion design, I designed a simple pattern using just 4 rectangles and a couple of circles to kind of cap the neck hole or armholes that you might have on a garment, and played with the various darts that I could create. So large to small, darts on the edge of the fabric versus in the center of the fabric, different spacing, different lengths, whether they're gradiating or variegating back and forth between a diamond and a triangle along an edge, and what those results could ultimately give me. So within the program Clo 3D, I could assign stitch conditions to each of these edges, and these seam lines were shown as different strings that connect those flat panels together, which is really beneficial compared to using an architectural program, which might not have these embodied sewing techniques built into the software, as well as material properties that can be played out and simulated. So when you start to simulate the stitching, it pulls the fabric together and shapes it into the locations based on those seam lines. And then given a material property, in this case, ripstop nylon, which is a soft material, kind of swishy, airtight material, can then be inflated and forced from the outside. And what you get when you have these pneumatic forms is this rounded object as it tries to reach equilibrium and bulbousy shapes as it pushes out. In the program, you can also simulate stress and strain to see where those moments are, where the fabric is being pulled too much or a lot of tension, which is really important when you're looking at making an article of clothing, how you might move or fit within it, as well as the rendering to just simulate what is the overall appearance and look of the draping and wrinkles of the form. And finally, comparing that to the actual physical result from a photograph of the same angle, you can see that the simulation was really quite similar to the resultant form, that even where some of the larger wrinkles or pinches in the stitching resulted and occurred in the same location on the final built physical form. And analyzing then what my different playfulness of stitches ended up creating different playful forms, where it's more bulbous, where it's more jaunty, different creases and folds and how it shapes was quite interesting. As the final form, you can see maybe similar to the fitted dress is that it's a bit more boxier in shape, that there are some straight kind of edges because the darts are cut at straight edges. This might change if you made sort of almond shaped darts rather than diamond shaped darts, and the wrinkles aren't too much, but the kind of few points where there might be some overall curvature does occur in different points of the model. One thing I realized is that the outside of the model didn't have that much dynamicism or wrinkliness, but if you flipped the model inside out and inflated it, the excess fabric from the darts, which sometimes can be cut away, could also be left as an element of excess skin or flaps that could be played with and engaged with on the form, as well as even when engaging in the environment, they would flap around in the wind or create shadows and lighting effects. The next model utilized pleats, which are commonly known as sort of a skirt area where you fold the fabric to connect a skirt to a bodice on a dress. And similarly, I categorize tucks to be the same as pleats and use those as well, as they are different ways that you can fold the fabric, but usually done more in the center of the fabric and in a more decorative way rather than just as a way to constrict the length of a fabric. Pleats, because of the way they're folded, and you can see here in both the box and knife pleat, it creates 3 layers of fabric, a front, middle, and back. This results in a 1/3 ratio, as the original length of the fabric to the folded length is 1/3 of its original size. And similarly, the open end of the skirt is the full length. And so this proportion was used throughout the design and understanding of how the different edges would sew together and create different lengths and openings. So different pleats and tucks were used here and explored with different spacing, different lengths, gradating from large to small, or large, small, to just be playful and explore what these results might be on the surface and overall form of the pneumatic structure. You can see here the simulated structure is then this very bulbousy element, and the pleats create these wrinkles and moments of pinch as it gathers the fabric together at the different points as it's sewn to smaller pieces of fabric. Resultantly, you can see through the stress and strain simulation that the areas where the tucks are really create a lot of strain on that fabric and a lot of pulling and pressure, which was hard to maybe understand through the meshing and triangulation of the geometry, still looking quite wrinkly at that point. In the actual final model, it began to rigidize and harden and create this tougher area as the fabric built up and became harder, as well as the amount of pressure forcing onto that part of the fabric. And it became kind of hard shaped and not as rounded as the simulation appeared. But there are elements in the design that are still quite rounded because of the different size ratios of the pleats and different ways and locations that they are created. Ultimately, it also created pinch points in the design as the different ways that the 1/3 pieces came together almost actually create these sort of tucks and bends and neck cinches that we get on our bodies as it really pushes in and out from that 1/3 ratio. Here you can see the different textures and different wrinkles and different ways that the fabric expands and contracts based on the sewing techniques used and how those results appeared on the final model. Ultimately, the way that your hands wanted to touch and feel the sensations of those folded pieces of fabric was really wonderful, and your fingers just wanted to slide in between the excess pieces of fabric and engage with them closely. The last model utilized gathers and ruching, which is similar to tucks and pleats, but it doesn't fold the fabric as much as it just pulls the fabric together in a more loose fashion, and is used at waistlines and on bodices. Gathers, you can see here, are created by using a running stitch and then pulling that thread to cinch the fabric up along that stitch line. And they don't have to be in a proportion that is so controlled like the pleats. You could cinch as much or as little as you would like along that thread line. But for this project, I wanted to focus on a controlled ratio of 1/2, so a little bit less than the 1/3, and allow for the fabric to always gather at that length for both the ruching and the gathered edges. So you can see on the pattern design playing out different types of ruching and different gathers as they maybe are different lengths, spacing, angled versus variegating across the fabric. Resultantly, we see here, when it inflates, it tries to really push that fabric out to create a smooth form at the points where it can, but those gathered and cinched elements still create all these wrinkles and constriction on the fabric. The physical comparison between the physical model and the photograph and the simulation of the rendered model, I couldn't line them up because of a sewing mistake that I had made and sewed one of the pieces backwards. But you can see on the simulation, the overall forms that are created have a bit more jauntiness or crinkliness because of the meshing of the geometry and the computational power that I had on my computer. And the final physical result is actually much smoother and much finer wrinkly textures. And the overall form is just so curvy and bulbous. It's just curves here, curves there, curves left and right, and all over the model are just so rounded and bulbous, as well as the types of wrinkles that were created and the way that the different wrinkles kind of twist or shift or expand or contract as they're played out in these various fun ways across the body of the object. Ultimately creating something that was just begging to be touched and squeezed and squished and had these almost like cute elements that you think of like a Shar-Pei dog or an anime character in its bulbousiness. So it was really fun to want to play with this fluffy cloud pneumatic object. Ultimately, looking at these sewing techniques and how they created different forms, you can see the results overall have various overall curvature as well as different textural qualities. And these are elements that I am hoping to continue to explore, how the curvature and wrinkles from our bodies could then be engaging within our built environment as a more tactile and more connected space to our human condition. Thank you for listening to my presentation.